Hi all, and welcome to this video on unit testing, where we'll be focusing on how to test a repository using an in-memory database. Now here we've got a very simple application set up with a simple repository pattern and a Postgres SQL database with entity framework core. Now normally when we test an interaction with a database, we would need an actual database to run tests against. Either that, or we can always mock our repository. Both of these have downsides, as having an actual database makes it more difficult to run in a pipeline, as you'd actually need a database to run tests against, as well as it being more likely that your unit tests are affected by other things in the database outside the scope of your tests. Take for an example that if you want to do a list of get all, but there's another unit test that's adding to the same database, then you might not get the exact amount of results you want, which would lead to flaky tests. Whereas mocking an entire repository would mean that you end up actually not testing the code inside the repository itself. So a nice middle ground for this is an in-memory database. This allows us to have a database-like storage that integrates with our repository, but without having to have an actual database available to test against. So let me show you how this would work. I've got a simple unit test class here, and we're going to start off by adding a NuGet package, and the NuGet package we're going to add is EF Core in memory, Microsoft Entity Framework Core in memory, and we're going to run version 6.4. Now, how we've got our repository set up is we accept an application context as part of the constructor, and then we've just got a save function. So the first thing we need to do in our test is actually create an application context. And to do that, and we'll go to the application context to see how it works, this has a constructor for the DB context options. So we need to create those options and then create a context. And we'll do that in our test, and we'll just say our options builder is equal to a new DB options. Oh, DB context options builder, sorry. DB context options builder. And then we pass in our context, which is an application context. And then we just want to do a dot and tell it what type of database we want to use. And we can say use an in-memory database. This accepts a name. And for ours, we're going to use a GUID. That means for each test, we will get our own little in-memory database, which is really, really useful. From there, we can create a context, if I could type to there. So that's a new application context. And then we can pass in our options builder dot options. From there, we'll create our repository, which is a new company repository. This accepts a context, so we can pass in the context. And we can just say repository.save and then just pass in a new company. And then we can say assert.single. Assert single just means there should only be one in this collection. And then pass in the context.companies. And if we were to run this test now, then we will get a success. The nice thing about this is if we could add data and edit data before we run our test, so we can make sure there's data in there in case we need that for our actual test we're doing. So take for an example a get function. I'll just copy this quickly, and we'll do a get, and we'll change this to a GUID because our primary key is a GUID, and we'll do it by ID. And rather than that, we'll just return a context.companies, and we can do first to default, where t_t.id is equal to our ID. We'll remove that unused code, and then we also want to return a company. And why is that mourning? Oh, it's a possible null reference return, so we will specify the question mark so it knows it can be null in this situation. Now that we've added that function, we can go back to our tests and we can write a test in it. And we'll start off simple. We'll just copy this again, and we'll change the name to test2 because naming things can be difficult. And this time, rather than repository save, we'll call repository dot. What did it? Oh, I didn't change the name of it. That was silly. And we'll call it repository get. Now this accepts an ID. So what we'll do before this is we will create our ID. Var ID is equal to a GUID.new GUID. And then we'll pass in our ID here. We'll set a value as its response, and we will assert that it isn't null. Now, obviously, when I run this, this is going to fail immediately because there's nothing in this database. So it's going to say, this isn't right, this is null when I return it. But what we can do is we can just say context.companies.add, and then we can add a new company, and we can just specify our ID as equal to our ID. Now, be aware, because if I run this again, I will still get a failure. I will still get a failure because I haven't saved the changes to the context. So I still need to say context.save changes. Now when I run this, it will pass. Now, we can make this a lot cleaner. Obviously, we don't want to have to do this in every test. So what we can do is make a class for it. We'll call it our context generator. We'll make it static, and we'll have a public static, and we'll return an application context, and we'll call it generate. We'll now, rather than do it here all the time, we'll just do this, and we'll return it from here. Make sure we inject these so it works. And now we've got a static class that can generate our context. So now in here, we can remove this and we can say var context is equal to context generator dot generate. And I will do that in both tests just so we know that it's working as expected. Oh, I only ran one there. I'll make sure I run two. Perfect. And now to clean it up even more, if we want to, we can turn around and make a constructor in our tests. And we'll also make a private read-only variable of the context, of an application context. And we'll just call that underscore context. And then we'll just say context is equal to, and we can do context generator.context here. And we can also remove that from our tests. And then rather than that, we can just use the underscore context everywhere. And again, if we run all these tests, then they all will work. Now, that's all nice. Everything's working. So does that mean there's no actual need for real databases in our tests? And unfortunately, the answer is no. And although in-memory databases are a really nice way of checking that data gets put in the database how it should, it doesn't actually validate that the data is correct. So it doesn't check that the relations are correct if it's in the essential relational database. So it wouldn't check foreign keys. It wouldn't check requirements. So let me give you an example for this. I'll go to our company and I will create a public string, and we'll just call this a test volume. And then if I go to my context, I will add that. So model builder.entity company. And we can say .property, and we'll do entity.test value. And then we can say .has max length, and we'll say a max length of 5. So in an actual database, an actual implementation, running this, or something saving with a test value of less than 5, of more than 5, sorry, should fail. So we'll do that we'll go to our unit test, and we'll go to the save function. and this time we'll add a test value, and we'll give it a value of clearly longer than 5. And if I run this test, it passes. So, based on this, should we actually be using in-memory databases if it can't validate and can't act how a database actually should? Now, this decision is debatable. Should we use it? Some people will say yes, some people will say no. Microsoft actually itself recommends not using it, yet they will continually put out packages for it for every release of .NET. My advice is that you can use them if you want, depending on the test you're running, but you should not use them as a be-all and end-all. If you're going to use an in-memory database, you should probably have a good set of integration tests that actually run against the database to ensure that your relations and your database integrity is actually correct. That's going to be the end of this video, guys. Thank you Thank you very, very much for watching. Don't forget to like and subscribe, and I will see you in the next one. Cheers.